Good morning, friends. I am here again for my course, Aircraft Systems. I am in Module 3 and this is the last lecture of the Module 3, lecture number 25. The topic of the lecture is landing gear systems, landing gear and the brake management systems. We have seen that, as you know that my name is Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. We have seen that in Module 3, we have covered the two systems, that is the hydraulic systems and the pneumatic system. And if we talk about the use of these hydraulic systems and pneumatic systems, it is very much required for the landing gear systems and the brake of the aircraft. So in this, how the landing gears are made, how the Oleo struts are made, how the shock absorbers are working, their functions and all. These are things I am going to discuss in this topic. Before I start to this topic, I should again revisit to my previous lectures, starting with my Module 1. So if I am writing here this Module 1. In Module 1, I have discussed about the basic systems of airframe system, that is A, airframe system. Then next I have studied about the vehicle system. Then I have just given the lecture on basics of avionics system. And the fourth one is mission system. If I talk about the airframe systems, I have taken the three main components. First one is the wing, second one is the fuselage, and third one is empennage. Now, I am here now in vehicle system, and in vehicle system in my Module 2, we have discussed about electrical system. Then we have discussed about air conditioning system, AC system. Then environmental control system. Then anti-icing, de-icing system, oxygen system, firefighting system. These things I have covered in Module 2. Now I am in Module 3, and in Module 3 we have seen two systems. One is hydraulic system and another is pneumatic system. Okay, so hydraulic system and pneumatic systems. So these things I have, hydraulic systems I have covered, pneumatic systems I have covered. This is the last topic of this Module 3, and where both the systems, that is hydraulic systems and the pneumatic systems, are working together. Mostly what happens is all the normal systems working by the hydraulic system, but as and when hydraulic systems are failed or there is some fault or some snags in the system, that time pneumatic systems will come into function. And you know that pneumatic systems, mostly they have a very high pressurized air bottles or nitrogen bottles, and these bottles can work for a limited time. So if you are working on the pneumatic system, these are the emergency cases, and in emergency cases only these things will work. So now I will go for today's my classes. In this, I will be covering the functions and types of landing gears, landing gear wheel arrangement, shock strut and Oleo strut, landing gear retraction system, landing gear positioning indicators, aircraft brake system, aircraft anti-skid system. So these are the systems which I am going to cover in today's class. It is really very interesting and it is very useful for any aeronautical or aerospace engineer to understand about the landing gear, because landing gears are used for aircrafts, helicopters, your spacecrafts, everywhere landing gears are used. So it is very much essential and to understand their concept and how these things are working. So I am going ahead with the landing gear system. So aircraft landing gear. So what is this landing gear? If you take the aircraft, it has to support it on the ground by some equipments. So here we have something and here we have something. These are called the landing gear. Landing gear means the equipments which are used for landing of the aircraft, for the parking of the aircraft, for moving on the ground on the tarmac or runway or any dispersal when our aircraft is doing some maneuver on the ground. These are done by the help of wheel and some management, some mechanism. All these things, wheel, shock strut, Oleo leg, mountings, and all these systems are called the landing gears. And these landing gears are very much important and very much necessary for any aircraft operation, because it carries the highest load and lot of impact is withstand by this landing gears. So function of the landing gear. So I have to discuss first what is the function of the landing gear and why it is used. So the landing gears are to support the static load of an aircraft on the ground or water during maneuver or in static condition. So whenever your aircraft is on the ground, it should support the weight, it should support the load of the aircraft, and during the ground maneuver and on the water also, because in water also sometimes you have to take off or land. So there is different types of landing gears, but those also, so either in the water or on the ground, so different types of landing gears are used. Either it is stationary in hangar or it is moving on the dispersal or the runway, it is running with a very high speed. Everywhere these landing gears are required, and these landing gears are used very effectively for all this type of operations. Provide a mean of ground maneuver taxiing. So these landing gears are also used for taxiing, handling on the ground, moving from one place to another place, doing for servicing. For takeoff, it is running on the runway. On the runway, it is coming to the dispersal. From dispersal, it comes to the tarmac where it is parked, and it is also going for the maintenance. All the motion on the ground is done by the help of the landing gear. These landing gears absorb the landing shocks. So whenever aircraft is landing like this, lot of shock is experienced by the landing gear. So this impact load, hard impact load is withstand by the landing gears, dampen the vibration. It is also required to, because due to the impact, this impact should not transfer to the aircraft. Otherwise the aircraft, the damage may take place, and the passenger and the pilots, air crew who are sitting on the aircraft, they will feel a huge amount of jerk on the body, and it will be very dangerous and disaster for the human being as well as for the equipments, because equipments also cannot sustain much vibration. So it is also to shock, to absorb the vibration, also to dampen out slowly the vibration after impact is experienced by the aircraft. Facilitate aircraft for takeoff and the landing. So during the takeoff, so what is the takeoff? This is the runway. Aircraft is here. Here is this, wheels are here. So it has to run like this, and after some time it has to climb. This is called climb. This is the ground run. Up to here it is a ground run. From here to here is a climb. So as and when it is running on the runway, total load is absorbed by the landing gears for takeoff. And during the landing, it will come like this in this direction. However, this angle will be 2.5 to 3 degree angle, not this much. So it will come like this. And after touching, a huge amount of impact is experienced, and you will see that the aircraft is landing like this, and it will go with a very high speed, and then it will stop somewhere here. Okay, so here landing gears and brakes both are very important during takeoff, I have just explained, and during the landing. Lot of loads, lot of type of aerodynamic characteristics, so many issues are there to handle the situation. Providing the aircraft the braking and steering function. It is also provide the braking because wheels are there, and these wheels has to be given the brake to stop the aircraft. Stop the aircraft during landing. During taxiing and all, whenever you want to turn, and that time also brakes are applied. So this also gives the braking capacity of the aircraft. Now I will discuss about the types of landing gears which are used on the aircraft, and this you will see that there are three basic types of landing gear that apply to the surfaces, which is the water. First one is the water, hard and earthen, and snow or ice. So this is the one case, this is the second case, and this is the third case. So three basic surfaces where the aircraft can land. One is the water. You might have seen some amphibian aircraft. They can land on the ground, they can land on the water, they can take off from the water, they can land on the earth or then on the runway also. And if snow or ice areas are there, especially in Europe and the Antarctica and all, so here we see that lot of snow and ice is there on the runway or on the surfaces. That time also, in case of emergency, we should be able to land and take off from that type of surfaces. So accordingly, we have different types of landing gears are used. Each surface requires a different type configuration of the landing gear. So each surface we need different types of landing gears. So basically we have the two types, fixed or the rigid type of landing gear, this one, and the retractable landing gear. We have the two types of the landing gear, and this I am going to discuss in the next slide. So fixed or the rigid landing gears. So aircraft that are not practical to be retracted are more suitable to use rigid or fixed type of landing gear. It is usually equipped with cowlings or fairings known as spat, speed fairing or wheel pants. So these are the names of the cowlings which are used, that is spat, speed fairings and wheel pant. So like we are wearing the pant, like this the wheels also wearing the pants. Here landing gears again, so fixed are the rigid. This you can see here the Cessna aircraft, and here if you see these are the landing gears, and these landing gears are the fixed landing gear. They are not retracted. It will be always open, and if you see here we have the pant. This is called the pant. So pant means it is covering the wheel and other things. Okay, so fixed landing gears hangs underneath an aircraft during flight. So it will be always hanging. Just you can see here in this aircraft, these wheels are, wheel is here, wheel, nose wheel, and this is two main wheel. They are the main wheel, and this is the nose wheel. Okay, so these are the main wheels and this is the nose wheel, and they are always hanging. They are not retracted inside. Whereas if you see the retractable landing gears, so this is the fixed landing gear and this is the retractable landing gear. Okay, so here we have whereas the retractable landing gear is stored inside an aircraft during flight, each arrangement and design is intended for a specific purpose and or desired performance. So as per the performance, as per the speed of the aircraft, if it is a low speed aircraft, we can keep outside. But if it is a high speed aircraft, it is very much, it will create the fixed type of landing gear will not be suitable because it will create huge amount of drag. So that time we have to use the retractable landing gears. Now I will talk about the retractable landing gear. In this, what happened that this is the aircraft. This is the nose landing gear, and here we have the wing. So this is the one I'm just showing here. So during the runway or during the landing and takeoff, it will be out, and after takeoff from here, all the wheels, they are outside, they are retractable inside and they are put inside the fuselage or the wing. The nose wheel, mostly it is mounted underneath the pilot, so it will retract inside and it will be covered. And if you see about the wing, it will go inside the wing and it will close. I will be showing this diagram in the next slide. So it is essential that we should use the retractable as and when the aircraft is in high speed zone. So minimizing the amount of parasite drag. So if you want to minimize the drag of the parasite by means of retracting the landing gear to its designed compartment known as landing gear compartment or wheel well area. So it is landing gear compartment, it is accumulated like this. It is inside the wheel the landing gear which are on the main wing, they will go inside like this, and the nose will come inside, and they will be nose will be going inside the belly of the fuselage, and the wing, the landing gears which are on the wing, they will go inside the wing. So like this, they are stored in the either in wheel well or the landing gear compartment. So they are stored there, and as and when they required to land, and again it will again come out, and aircraft will be the same outside configuration. Also contribute to more better and improved aircraft performance. So first thing, it is drag reduced. That is the very important thing. So fuel consumption will reduce the performance, and another is to improve aircraft performance. So these are the basic things for which we use normally retractable landing gear for high performance aircrafts. This you can see here. If you see the first one here, it is the retractable here. It is a fixed one here. These are the fixed one. This one. But if you see here, in this aircraft, wheels not visible. Wheels not visible. So it is retracted. Okay, this you can see here. These are inserted inside as and when required. This you can see how they are going inside in this belly like this. In this diagram, they are just entering inside, and these doors will close like this. So you cannot see that there is a wheel inside this. It is a closed compartment. Here also this you can see nose, and these are the main wheels. 1, 2, 3, 4, 5 like this. So this will go inside the fuselage, and this will go inside the wing. This nose and this 1, 2, 3. This will go inside the fuselage, but the wing, the landing gears which are fitted on the wing, they will be inserted inside the wing. So different aircrafts, as per their load and their other capacity, they have different types of landing gears, and these landing gears I am going to discuss in the next topics. So in this I am going to discuss about the landing gears again, LG. So here arrangement of the landing gears. So how many types of arrangements are there? First I will show the single type LG. So here only one wheel will be there. In one landing gear, only one wheel will be there. It is called the single type landing gear. If one axle, here is, okay, this is the axle, only one wheel. Here one axle, two wheel. So it is called the double type landing gear. Next one is the tandem type LG, parallel to each other. So here if you see in the one landing gear, two axles are there, but they are the parallel. Axles are parallel. So it is called the tandem type landing gear, and this is called the bogie or multiple or the bogie type landing gear. In one axle we have the two, and another axle we have the two, and both are in the one Oleo leg. Both are fixed. In means each axle we have the two, and there is a two axles. We have the two axles, and each axle's two wheels are there. So it is called the multiple or the bogie type of landing gear, and this you can see here what is the difference between these landing gears. I will talk here basically the bogie type, because this is used for all big aircraft, and this single and double, these are used for small aircrafts like Cessna and all. But the bogie type of aircrafts are Boeing, Airbus, or the Airbus 320. All these bogie type of systems are used. The number of wheel arrangement determined by the gross design weight of aircraft and the surfaces on which the loaded aircraft may require performing landing. So, as per the load of the aircraft, which type of landing gear we have to use. So, advantage of multiple wheel type of landing gear. So, like bogie wheel we use many aircraft, especially the bigger aircraft. So, what are the advantages of this type of wheel? Number one, multiple wheels spread the aircraft weight over a larger area of load distribution. This you might have seen this and this, another is this and another is this. So this much area is covered. If you take only one, only very small area is covered. But if you take area is many times, it is covered. So per unit area, load capacity of the landing gears are increased. So that is the first purpose, that multiple wheels spread the aircraft weight over a larger area of load distribution, providing safety margin in case of one or the tire burst during takeoff or landing. So suppose here 4, here 4, here 4, here 4, like this. If one or two tire burst also, aircraft safety is not jeopardized. Safety is maintained, because lot of accidents have happened due to the bursting of the aircraft wheels. So if the aircraft wheel is burst, then it is very, very risky for again to land the aircraft. Takeoff is done, but how you will land? So try to avoid that by the truck type or the bogie type of landing gears are used. So landing gear wheel arrangement, this another one, this we can see here that different diagrams are here. So first one is tail wheel, conventional type wheel. So in this, here we have the tail wheel. This you can see here, this is called tail wheel. So in this, towards the tail you have the one wheel, and in the wing or on the front side of the fuselage you have the two wheels. Initially this type of aircrafts were used, but what are the advantages and the disadvantages of these aircrafts I am going to discuss in this. So main landing gears are located ahead of the center of gravity, with tail wheel acts as an auxiliary landing gear. So these main wheels are, they are called the main wheels. These main wheels are ahead of the CG. So assume that CG is somewhere here in this. So main wheel is ahead and tail wheel is behind. So here main landing gears are located ahead of the CG. with tail wheel acts as an auxiliary landing gear, steering the aircraft by means of tail wheel through the application of brake by rudder pedal known as a differential brake. So steering the aircraft by means of tail wheel through the application of brake by rudder pedal known as differential braking. So we use the differential braking by the rudder pedal. Extra pilot skill is required to land the aircraft as aircraft tends ground loop and the CG may swing ahead of the main wheel, which may cause abrupt uncontrolled change in direction of aircraft in ground. So these are the some advantages and the disadvantages. Extra skill is required to fly this type of aircraft. Pilot need extra skill because he is not aware that where is the CG. Aircraft tends to ground loop. It will try to ground loop and the C of G may swing ahead of the main wheel, which may cause uncontrolled change in direction of the aircraft ground. So this is for the tail wheel or conventional type of wheel. Another is the tandem wheel. If you see here, tandem wheel are forward and ahead. In just like this, this, and this. This is the tandem. It is shown here. They are parallel. It is called the tandem wheel. And if you see here that what is the use and the advantages of. So in this main landing gears are located in line of the CG. So mostly these main landing gears are just below the CG, which is under the fuselage, and a large wing is supported by outrigger wheels. So in this what happened? I will show you here. It is not clear in this diagram. I will show you that here is one wheel and this is one wheel. But if you see, this is the wing and this is the wing. Here also two wheels will be there. So these wheels will support, but main load is taken by, this is called the tandem wing. Tandem wheel arrangement. Okay, so this is the main landing gears are located in line of the CG, near the CG, which is under the fuselage, and large wings is supported by outrigger wheels. These are called outrigger wheels. Okay, this type of wheel you can see in fighter aircrafts. They are having such type of arrangement, especially in carrier type of aircraft like Sea Harrier and all. We have such type of configuration. Now the tricyclic arrangement. This is nowadays used in most of the aircraft. It is nose is ahead and the main wheels are behind. So main landing gears are located aft or behind the CG, with nose wheels act as the steering and auxiliary gears. So nose wheel is acting as a steering. Actually, it is not used to absorb the main shocks. Main shocks are absorbed by the main landing gear. These are the main landing gears. Main landing gears. But this is used to support as an auxiliary gear and also to give steering the direction on the ground. So that is the purpose of. So here we have seen that tail wheel or conventional type of wheel. It is in this, the two front wheels are there and one is the nose wheel. It is not good for so many reasons. Mostly nowadays we don't use. Then we have the tandem. This type of used for the parallel, two parallel, and these wings are supported by outriggers wheels. And the third one is the tricyclic. This tricyclic are used main landing gears and then nose landing gears. advantage and disadvantage of the tail wheel arrangement. So this is the tail wheel arrangement. So I am going to discuss about advantages and disadvantages of this arrangement. So advantage of tail or conventional wheel arrangement, there is a one advantage: using a shorter runway path cause as the tail down attitude gives a high drag after landing. So in the landing it is good. For landing it gives additional drag and that makes a less runway requirement. So using a shorter runway path cause as the tail down attitude gives a high drag after landing. Okay, so you might have seen that if it is like this, the aircraft will be looking like this. So it is nose up. So this nose up, it will give better landing capacity of the aircraft. What is the disadvantage of this tail or conventional wheel arrangement? Brake application must be delayed or monitored closely to avoid the tendency to nose tilt. We have to make sure that brake application, because in both the front wheel, if you make the brake little, one is more, another is less, it will try to turn very fast. So that is the one very disadvantage. A pilot view is restricted when taxiing and great care during taxiing is required. So if you see pilot is here, he cannot see the proper runway because his orientation is like this. So it is for the pilot, the view is not very much clear. A pilot view is restricted when taxiing and great care during taxiing is required. Now, advantage of tricyclic wheel arrangement. Mostly we use this type of arrangement nowadays. So what are the advantages? So here we see that the first advantage, it allows more forceful application of the brake for higher landing speed without nosing over. So it allows more forceful, you can apply more forceful because your main brakes are applied in main gears and your nose is free. So it is not affecting much. It permits better visibility for the pilot during the landing and the takeoff. So it is better visibility for the pilot. More forceful application of the brake. That is the first point. The second point is it permits better visibility for the pilot during landing and takeoff. It tends to prevent aircraft ground looping by moving the aircraft C of G forward of the main wheels. Forces acting on the C of G tends to keep the aircraft moving forward on a straight line rather than ground looping. In this, we will not have the ground looping because CG is mostly ahead of the main. It will give support for moving the aircraft ahead. But if you are having the tail type, it will give the reverse section. It will try to ground loop. It will try to go up. So that is the disadvantage of the tail type of configuration or conventional configuration. Those disadvantages are taken care by the tricyclic wheel arrangement. Landing gear main components. This you can see here that I have shown this landing gear and what are the components here. This you can see one by one. If I start, it is a forward motion and it is a INBD. It is a forward motion. Aircraft will move in this direction. So if I start here, this is the beam hanger. Then we have the main gear actuator. This is the main gear actuator. This will try to actuate. Then we have the walking beam. This is called the walking beam. Then here we have ground speed brake cable. Here we have the ground speed brake. These are the brake cables. Trunnion link. This is called the trunnion link. This is called the drag strut. This here. This is the drag strut. Universal side strut fitting. This is the universal side strut fitting. Here you have the damper hydraulic line. This blue line is hydraulic line. It is called the damper hydraulic line. Main gear damper. Here is the main gear damper. This one is the main gear damper. Then we have the torsion link. Here is you have the torsion link. This is the axle which is joining the wheel to this shock strut. Then we have the gravel deflector. This is used to deflect the stones and other small items. This is the uplock miller. Here this is the uplock miller. This one uplock miller. This is called the shock strut. This whole system from here to here. This is the shock strut. Okay, so this we have to shock strut, side strut. This is called the side strut. This is the down lock. Here is the down lock. This is the uplock and down lock. Here is uplock actuator. A small actuator is here. It is uplock actuator. This is the reaction link here. Reaction link. Down lock actuator here. Down lock apring bungie. It is some rubberized bungees here. This is called the down lock, and this is the walking beams. These are the very important some of the parts of the landing gears. We should know each name and what are the function of each part, that we should understand. Now the next is the shock strut and the oleo strut. So there is a little difference between the oleo strut and the shock strut. If you see here in the shock strut, you have the hydraulic systems and there are number of holes. So these shocks are absorbed very nicely in this. Oleo strut this is the one only oleo, and it is for a small aircraft we use oleo strut, and for a bigger aircraft where we need a lot of impact load and lot of vibrations are there, that time we use the shock strut. So a type of hydro-pneumatic oil and air compressors. So what are the shock strut and the oleo strut? Both are the hydro-pneumatic. Air and the oil or hydraulic fluid is there. So it is a type of hydro-pneumatic component. A device in an aircraft landing gear system that absorbs the landing shock, which occurs when an aircraft touches down when landing or during taxiing. So during landing or the taxiing, these things are used to absorb the shocks of the aircraft. Functions of a shock strut: absorbs and dissipating landing shocks, incorporates of a telescopic tube mechanism which absorbs landing shocks but resists rebound and at the same time protect the aircraft structures. Absorbs and dissipating landing shock, incorporates of a telescopic tube mechanism which absorbs landing shocks but resist rebound and at the same time protect the aircraft structures. Controlling the rebound, spring back or recoil moment. So spring is there, so it will try to work like a spring. Provide cushioning effect during taxiing. So during the taxiing, the shocks are not observed to the aircraft or the passengers or the instruments. So these are the functions of the shock struts. Shock strut type and the advantage. There are two types of shock strut. One is a non-absorbing shock struts and the second one is the absorbing shock struts. So non-absorbing means it is a very rigid type, and okay, like here, this you can see in helicopter. It is just a rod and it is just coming and landing like that. So it is a non-absorbing shock strut. So we have the rigid or skid, we have the spring steel, we have the composite, we have the bungie cord. So these are the four types of non-absorbing shock strut oleo. So rigid, this you can see here, it is very hard and it is called skid. Then sometimes we use here some springs here. If you use some springs, it becomes a spring steel. And sometimes we use both spring steel and the rigid. And sometimes we use some rubberized component, some rubber type of materials like this, a pad here. So this rubber material will absorb some small amount of shocks. So rigid type shock strut, it is called non-absorbent, commonly found on helicopter skid and the sailplanes. So they are used for the helicopter as shown here, and the sailplanes which are used for the like a glider. The strut is rigidly attached to the aircraft without no specific component to cushion the ground contact. The only way of cushioning is no more than through the flexing of the landing gear or airframe structure itself. Now, I am going to discuss a shock absorber. It is very important part of any landing gear. It absorbs the whole amount of shocks impact load of the aircraft, and it makes the aircraft very comfortable and safe. Utilize the energy stored in compression of a liquid. Most liquids are known to be incompressible, but liquid spring type strut uses synthetic silicone based fluid with molecules that are constructed larger than the usual. Fluid contraction is a problem as fluid volumes changes at low temperature and affecting the Oleo performance. So fluid contraction is the problem. So if the fuel is contracting the volume, so it should be incompressible. It should not be contract. So if it is able to contract, then the performance of the landing gears will be reduced. Can only be pressurized while the aircraft is on jack, and the gear should be fully extended. So these are the some disadvantages. Equipped with a gland assembly that prevents leakage of the cylinder content whenever the cylinder pressure is applied by the principles of differential pressure. This you can see here. This is a spherical bearing here. We have a rod here. We have the rebound stop here. This is the rebound stop. Gland with seal package. So here is a gland, piston and the primary damping here, and spherical bearing here also and here also, and this is the port, and like this is simple liquid spring shock. In this spring is there and the small liquid is there. A very simple shock absorber is shown here. Now next is the Oleo pneumatic with separator landing gear. Another type of, in this Oleo pneumatic with separator landing gear. So it consists of an outer cylinder in which slides a plunge tube or the lower cylinder. So here this you can see a outer cylinder is there and there is a lower cylinder is here. This one, this you can see here. Just I will show you this. So here is the axle, where wheel is, here is a wheel. This is the wheel will be fixed here. Then we have here piston. This is the piston. This is the lower bearing here. This is the seal so that the hydraulic fluid should not enter. This is the metering pin is here. This is the metering pin. This is the recoil valve. Upper bearing is here. Lower bearing and upper bearing. Orifice here. So it's a metered amount of hydraulic fluid should enter or go. Here is hydraulic fluid or oil. Upper chamber, air is there. Here air is there. Here is air valve. This we can charge from here. Orifice support tube. This is the orifice support tube. So this is the Oleo pneumatic with separator landing gear. So it consists of an outer cylinder in which slides a plunge tube or the lower cylinder. Lower cylinder is prevented from rotating by torsion link secured to the outer cylinder. Lower cylinder contains a spring-loaded flutter plate which normally covers holes drilling through the head. Next, a small holes outside the diameter of the flutter plate. A floating separator in the lower cylinder separates the oil from the gas. Top of the outer cylinder is closed and fitted with two oil filler plug. Bottom of the lower cylinder is fitted with gas charging valve. So this you can see here. We have some lower bearing, upper bearing. We have here this piston. This piston will move, and here we have a small orifice. So as and when the impact will take place, this will try to go up. Due to this, here it is air charge, it will try to press the air, and this hydraulic fluid will enter by this orifice. So the shocks are observed by transferring the energy from one medium to another and from another to another. So like this, the transfer of energy in shock absorbers are taking place. So it is called the Oleo pneumatic with separator landing gear. In this, landing gears are separated from air and the fluid. Landing gear retraction system. So we have seen that in the aircraft, especially for high performance aircraft, we don't use the fixed landing gear. We use the landing gears which can be made out, and after out it can be go inside. So making inside, and it should not be visible, it is inserted inside the fuselage or inside the wing. This type of landing gears are called the retractable landing gear. So in this, if you see, to lower the landing gear, the pilot moves the landing gear handle to the gear down position, and these events take place. So if you see here, how this thing, pilot will put a lever down. If he is putting the lever down, then what will happen? The landing gear handle actuates a switch that turns on the hydraulic pump motor in the power pack, so that it turns in the direction shown by the arrow in the figure A. So if you see here in this figure A, the fluid is moving like this. Direction of this thing is like this. So all the three, nose and main. This is the main one, this is the main two, and this is the nose one. So if he is putting on, fluid will go like this and your system will be operated. Now, fluid flow through the passes and check valve on the right side of the pump and around the outside the gears. So this fluid will move from the passes and the check valve, and this you can see here. We have the gear up check valve, gear up check valve position here. We have here shuttle valve here. We have the low pressure control valve here. We have the reservoir, we have the filter. All the systems are operated here. Pressure switch is there, thermal relief valve is there. This is used to monitor the temperature. So these all things will work. So fluid flow through the passes and check valve on the right side of the pump and around the outside of the gears. The output from the pump moves the gear up check valve piston to the right and unseat the gear up check valve. Now, emergency operation of the landing gear. Okay, how the emergency operation of the landing gears are performed. A means of extension of the landing gear and locking it in down position in case of the main hydraulic system fails on a certain causes. On some aircraft, the up lock mechanism released by means of manual or by means of an emergency pneumatic system. The landing gear is free to fall under its own weight and down lock engaged by the spring jack. So a means of extension of the landing gear and the locking it in down position in case of main hydraulic system fail is called the emergency system. If your main system failed, that time how it will operate? So on some aircraft, the lockup mechanism is released by means of manual. The pilot will push a handle or it will break the system and it will go down, and there is a spring mechanism, it will lock the system. So it will fall like this and it will hold. So in the out position, it will be hold. The landing gear is free to fall under its own weight and down lock engaged by the spring jack. Fourth point is red light indicates the unsafe condition, such as the landing gear is not down and still is unlocked, or down position, or vice versa. So indicates that landing gear is still in transition from up to down position or vice versa. If the right is red, it means it is not locked properly, or it is released from there but is on the way. If no light is there, will indicate that landing gear is fully up and locked. So if it is up and locked, you will not see any light. Gear warning devices are incorporated in all retractable landing gear aircraft and usually consist of a horn or some other aural device and red warning light in form of audio or the visual warning. So, gear landing devices are incorporated in all retractable landing gear aircraft and usually consist of a horn or some other aural devices. Some sound will come. Some warning sound will come. Warning sound, beep will be coming so that the pilot will understand that there is a problem and it is not locking properly. On other aircrafts, meanwhile, the landing gear is extended by emergency pressure system that often uses alternative pipelines, tubing to the actuator, standby hydraulic system. So, main hydraulic system, then standby hydraulic system. Hydraulic pressure for emergency system may be applied by means of hydraulic accumulator, hand pump, pneumatic storage cylinder or the electrical power pump. So these are the secondary systems by which hydraulic system has to be operated. It may be the hydraulic accumulator where the high pressure nitrogen and the high pressure hydraulic is there, and for the time being the system will be operated. And then we have the pneumatic storage bottle or the cylinder, or if it is not there, some electrical power pumps are also used to operate the hydraulic system. Landing gear positioning indicator. So, how we see that the landing gear is in which position? It is locked up or locked down or it is in between. So, we should know that where is the position, and this position, it is indicated on the cockpit and the pilot will observe, and accordingly he or she will take the action as required. An electrical indicating system is used to provide visual indication to crew of operating regarding the LG, landing gear lock, and the position of the landing gear itself. Okay, so it will provide the position whether the landing gear is locked or unlocked or it is in between. Indicators are usually located in the cockpit or flight compartment. Green light is to indicate that the LG is down. That if the green is there, it is okay. It is properly down and the lock. Means down and the lock, then you will get a green light. So here this, you can see the positioning, landing gear indication, 3 color coded indication we have. One is a green, another is amber, another is a red. So if you are seeing the green, it means everything is fine. Your landing gear is down or up and it is locked. That is the indication. If you see the second, here is the amber light in transition. If the amber light is working, it means your landing gear is in between. It is not up, it is not down, it is transitioning from up to down or down to up. This is indication by this amber light. But if you see the red light, this red light indicates that aircraft down, up, not locked. It is down or up, but it is not safe. It is not locked by the system is still working, and you cannot land if light is red. You cannot land also if it is amber light. You can only land as and when you have the green signal. That time only all the systems are working properly, and that time only you can land. Now, aircraft brake mechanism. Brake mechanism is for the wheel brake, a mechanism to convert kinetic energy to heat energy by the friction. Brake systems are designed to rotate, retard or stop the aircraft motion on the ground. They are also an aid in controlling the direction of the aircraft while it is taxiing and application of brake. While the landing gear wheels are being retracted, applying either one or the both brakes. Brakes can be applied by using the toy pedal attached to the rudder pedal or by a hand brake lever, basically for the purpose of parking. If you want to park the aircraft, a hand brake, just you have to put like this, and all the wheels, a brake will be locked. Just like in your car, you have a handle. Same way in a aircraft also, you have a handle. Just you have to pull up and turn it like this. It will be locked. As and when you switch off, you just turn again and put down. Though your system will be released from the pressure. The greater the toy pedal applied, the larger will be the pressure transmitted to the brake. As much you are pressing your pedal, that much pressure is applied and that much brake will be applied on the aircraft. Here we have some brake systems arrangement composed of two subsystems, which are brake actuating unit and brake actuating system. We have this two type of systems. Brake actuating unit, a system and a component that slows down the aircraft movement and is located at the wheel and converts or changing kinetic energy from the motion of the aircraft into heat energy by means of the friction. Brake actuating system, a hydraulic component, is the aircraft that allows the pilot to control the amount of friction of a wheel unit produced. So here this you can see that a brake actuating unit, different here you have the pumps, you have the other systems, and these are applied on the typical brake system installation. Here is from the normal braking. These are the shown some diagram. Brake unit layout. This you can see here that we have some abrasive material here, and these are the, and it is operated, it is pressurized by the, and they are coming together, and all the parts are shown here in a sketch. Next is aircraft anti-skid system. These systems are used for the operation of the, your aircraft should not skid on the ground during the wet weather or these conditions. These are the used. Now next topic is my module 4, which is the engine and engine control systems. In that I will be discussing the types of engine controls, fuel systems and other type of systems. I have the references from Moyer and the Seabridge, aircraft systems, mechanical, electrical and avionics systems. We have design and development of aircraft system and introduction. And this is, if any questions, you are welcome to ask. And thank you very much. Here is my email. This you can mail me if you have any query. I request you to subscribe this channel and see this channel, and also convey your message to others so that everyone will get the benefit out of this. Thank you very much for joining this class. I am ending my session here. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.